Welcome back to the next part of the VLAN mini-series, where we are going to set up our VLANs using what we call VLAN filtering, which for most is going to be the superior method. Then we're going to find out how what we learned in the last video is complementary to this setup. And finally, we will try out yet another third method which will suit slightly older, cheaper CRS switches. This time around, I will use the same devices in the same physical layout, but I have removed all the previous configurations on everything. Before we begin the configuration, I would like to first explain how this is going to work. Previously, we used VLAN interfaces, and the working principles of such an interface are very simple. You give that interface an untagged frame, it adds a tag and sends it out the physical parent interface. Similarly, the physical parent interface receives a tagged frame, passes it on to the VLAN interface, which untags it before moving it forward. Now with VLAN filtering, all that tagging and untagging is going to be executed by a bridge interface instead. A bridge interface in RouterOS is just like any other interface. It has a MAC address and its own MTU. But more importantly, it has several properties relating to VLAN that are ignored until VLAN filtering is enabled. So far so good, but there are a couple of complications with using this bridge interface for VLANs. We need to understand them and account for them. First of all, bridges have multiple ports, and a bridge interface can be working with multiple VLANs at the same time. So we no longer have a two-ended interface where you add tags at one end and remove them at the other. We will have to think about our bridge ports individually, what VLANs they are working with, and what actions need to be taken on ingress, frames coming into the port, and what actions need to be taken on egress, frames leaving the port. Ingress actions being accept or drop tagged, untagged or incorrectly tagged frames to have the wrong VLAN ID, and to further assign them to a particular VLAN if accepted. Egress actions being tag or untagged frames that are leaving through a particular port. Another major complication is the dual nature of RouterOS bridges. When we create them, we are doing so using the CPU, and all the configuration is stored in the operating system as instructions for the CPU. It is a software bridge. But if that bridge can be hardware offloaded, then those instructions will get passed on to the switch chip, which means that Ethernet frames can be processed without the CPU even acknowledging them. That's why if you run the sniffer on a hardware offloaded bridge, you do not capture anything. Unfortunately, this also means that sometimes when we refer to a particular bridge in our configuration, it is easy to get confused between the software bridge and its switch chip doppelganger, because the same name can refer to either. This will become apparent later. We'll have hardware offloaded VLAN filtering setup, and we will add an additional VLAN that does get processed by the CPU. Okay, let's get started with our configuration. The first thing I must do is to create a bridge on the CRS. VLAN filtering is off by default, and we will leave it so for now. Next, I will add the ports that I want to use for VLANs. Due to hardware offloading limitations, you probably want all your ports to be in a single bridge anyway, but you do not have to put all your ports into VLANs manually, because by default the bridge and its ports are included in VLAN 1. And any ports that are not configured otherwise become untagged access ports to VLAN 1. If you particularly don't like that behavior, you can prevent it by simply setting the bridge itself to admit only VLAN-tagged frames. But you don't have to do that. Simply remember that the unconfigured ports will work just as if they were regular bridged ports thanks to VLAN 1. If you are just starting out with VLAN filtering, I actually recommend that you do not bridge all of the available ports. Leave out one or two, because it is very easy to accidentally mess up your VLAN setup and make the board completely inaccessible from all its bridged ports. I will just add the 3 ports that I'm using at this time, and as I do that, I need to specify some VLAN properties regarding ingress traffic. For the most part, we can view the bridge port section as our VLAN ingress configuration and the VLAN table in the bridge VLAN section as our egress configuration. But there will be a couple of exceptions. Ether24 is going to be my trunk port. So when I add it to my bridge, I want to set the frame types property for this port to be admint-only-vlan-tagged. This way, any frames that do not contain VLAN tags will be discarded immediately. It is not mandatory to use this parameter, but without setting it, you are creating a hybrid port and not a real trunk port, which is not advisable in security-sensitive environments. Next, I will add Ether16 with the PVID set to 10 and Ether8 with the PVID set to 20. The PVID stands for Port vlan-id. It is like a label that allows the device to sort out traffic for internal processing based on what VLAN it is intended for. This is happening before the actual VLAN tag is added because some of this traffic could be leaving the device through access ports where egress frames are untagged. For both Ether8 and Ether16, we set the frame types to admit-only-untagged and priority-tagged, which means that the only accepted frames will be ones without a VLAN tag or ones that have a special kind of tag, VLAN0. VLAN headers contain 3 bits that are for the class of service identifier, which in other words is just a number indicating traffic priority, and it can come in handy in high congestion scenarios. VLAN0 frames are treated just like untagged frames, except that they have this priority tag. Hence the frame types parameter groups untagged and priority tagged frames together. If we print the ports, we can see that our trunk port Ether24 has been automatically assigned to PVID1, but that doesn't matter because it is only used to sort untagged incoming traffic. But we set the frame types to admit-only-vlan-tagged. There is another ingress parameter that gets set up automatically. If we do print detail, we can see that our trunk port Ether24 has ingress filtering set to yes. This means that besides only admitting VLAN-tagged frames, it will also check the vlan-id. And the vlan-ids that are accepted will actually depend on the configuration that we do in the bridge VLAN section. So this is one spot where the line between ingress and egress configuration is a little blurred. With that being said, let's move on to egress. To add a VLAN entry to the VLAN table, you have to specify the bridge that you are working with and a vlan-id for which you would like to configure egress. And finally, add a port or multiple ports that will get their outgoing frames tagged for this particular VLAN. If you have multiple VLANs that simply need to be forwarded between trunk ports, then you could add multiple vlan-ids in a single entry. But since I have access ports for my 2 VLANs, I need to create 2 separate VLAN entries which share the same trunk port. And that is our egress configuration complete. Now you are probably wondering, what about the access ports? We could have specified them manually as untagged ports when adding these entries, but we don't have to because they will sort themselves out dynamically based on the PVIDs that we set on the port section. This is another spot where the line between ingress and egress is a little blurred. If we print the VLAN table, it doesn't look like much, but as soon as we enable VLAN filtering, this table will populate itself with current tagged and current untagged properties, which will make everything much more clear. Well, that is if we were to access the CRS from some other port to view this table. As you will see in a second, we will no longer have access from Ether24 when we enable VLAN filtering. Let's add both VLANs to the laptop, just like we did in the previous video. Also adding some static IP addresses so that Linux routes are not messed up. And I'm also adding more explicit connection names so that they are easier to tell apart. After that, we can open up Winbox and see the devices at the other end of our VLANs are showing up in neighbors. Also, we can easily verify that we are connecting through the VLANs, just disable VLAN 20 and L009 disappears from the neighbors. Do the opposite and disable VLAN 10 and you only get L009 in the neighbors. If we try to connect using its MAC address, it works. In the previous video, I said we will make our CRS invisible, and we did not see our CRS in the Winbox neighbors. But if we look at the neighbors of the L009, we can still see the CRS because untagged IPv6 neighbor discovery frames and untagged MNDP frames might still get broadcasted on your VLAN configured ports. But it is completely impossible to connect to the CRS, so neither of the devices on our 3 configured ports could make login attempts on the CRS, and hence it cannot be brute forced. Furthermore, VLAN hopping is also not possible due to the ingress filtering. Only the trunk port can connect to both VLANs. The access ports are stuck in their particular VLAN. This is a very secure setup as it is, but if you want to go further, you can configure your neighbor discovery properly so that it is only active on management ports. That way, the only giveaways about this switch will be its MAC addresses that, as you know, contain a short vendor identifier. And even then, you can go further and change the CRS MACs if you are paranoid or you're doing some sort of man-in-the-middle thing. However, you might not want to hide your CRS from everyone. Perhaps you or some network administrator will need a way to manage it. In that case, you could set up a management VLAN that you could weave through your network just like any other VLAN. In this case, my trunk port is directly connected to the laptop. But in a real-world scenario, the trunk port would likely connect to some other switch that might be connected to another one, and so on, with the administrator somewhere at the other end. Therefore, it would make a lot of sense to set up a management VLAN that is shared between the network equipment and the administrators. Let's do that by combining everything that we have learned so far. We have a working VLAN filtering setup, which is hardware offloaded, and now we will introduce a VLAN interface that needs to be processed by the CPU and ensure that the VLAN gets forwarded through the switch chip. I just need to plug into one of the unconfigured ports to access the CRS. On the interface VLAN section, add a new interface with the bridge as the parent interface and assign an IP address. Next, we need to make sure that our new VLAN is taking part in the VLAN filtering process on the bridge. On the interface bridge VLAN section, specify your bridge and your management VLAN ID. Then under tagged ports, add Ether24 as it is our trunk port. But then here is the counterintuitive part. Also add your bridge itself. Due to that dual nature of RouterOS bridges that we talked about earlier, when you create a VLAN interface that has a bridge as a parent interface, the tagged frames that would normally be leaving a physical interface are not just injected into the bridge. There is a gap that needs to be crossed, and it will be done under the hood if we add the bridge as a tagged port. Only then do we have a tagged communication between the management interface and the physical interface that serves as a trunk. I can now plug back into Ether24 and set up the management VLAN on the laptop. Simply add a new VLAN with the new ID, and since we assigned an IP address to the VLAN interface in RouterOS, we can use an IP from the same network. After that, the IP address of your management interface should show up in Winbox neighbors, ready to use. Now you have the basics that you need to work with VLAN filtering in all of your RouterOS devices. You could create additional trunk and access ports to work with either the VLANs we created in this demonstration, or you could create completely separate new ones. Another thing you could do is grab another switch and configure it in the exact same manner with one trunk and 3 access ports for our 3 VLANs. If we then connected the trunk ports of these 2 switches, we could remove the VLAN configuration from the laptop and connect to one of the 3 access ports. Depending on which access port we plug into, we will have access to either the HAP-AC², the L009, or the CRS326. This VLAN filtering method is great, and it will be completely hardware offloaded on our latest CRS switches and even the CCR2116 and CCR2216 routers. This is awesome, but this is an old CRS112 that, among other lower-end RouterOS devices, cannot benefit from the hardware offloading in this manner. However, CRS1 and CRS2 series switches have pretty good switch chips that can handle VLANs for us, but they have to be configured differently. Let's pay respect to the older generation and configure this guy with hardware offloading enabled. I'm going to use Ether2 as a trunk port and connect it to Ether24 on the CRS326. Ether 4, 6, and 8 are going to be my access ports. For now, I will connect my laptop to Ether 7. Starting with no configuration, I can create a bridge and the respective ports I will use. Also, we have to manually set HW to yes. This enables hardware offloading. Next, we can handle our ingress by going to the interface Ethernet switch ingress VLAN translation. There, we add our access ports one by one. Specify the customer VID as 0. This will include regular untagged frames as well. After that, we can handle our egress in the egress VLAN-tagged section by adding 3 vlan-id entries for our trunk port. On these switches, we also have to go to the switch VLAN section and manually specify which ports belong to which VLANs. In this case, we are basically pairing up our access ports with the trunk port. Finally, we should go back to the switch section and type in this long parameter. Drop if invalid or source port not member of VLAN on ports. Set it to all the ports that are used in our VLAN setup to have the switch check vlan-ids for security. Now I can disable and delete the VLANs on my laptop as I will be using access ports instead of the trunk port. Let's try them out. Ether 4, we find HAP-AC² and connect to it. Ether 6, we find the L009, and of course, the connection works. Now, what about Ether 8? Well, nothing shows up because on the management VLAN, we used layer 3 configuration. Let's see what happens when we add an IP address from the same network as the management interface. A correct route is created in Linux, and if we refresh the Winbox neighbors, the CRS326 shows up and it can be accessed. There is only one last thing missing. The CRS112 does not have a management interface. I'll change the ports one last time to show you how easily that can be done. Just add a VLAN interface as we did on CRS326 with the same VLAN IDs and an IP address from the same network. Then go to Interface Ethernet Egress VLAN tag, and since we already have VLAN ID 99, we have to edit the tagged ports property of the existing entry. And here, unlike the CRS326, where we added the bridge itself, we add a special port named Switch1 CPU. Finally, go to the Switch VLAN section, where we again need to add the Switch1 CPU port to the existing entry for VLAN 99. Now, if I plug into Ether 8 for one last time and check Winbox neighbors, I can see both of my switches, and of course, I can connect to my CRS112. That's it for what's probably the most detailed, thought-through MikroTips video so far. I feel we took this to a whole other level entirely, and it wasn't easy. But was it worth it? Let me know in the comments. Did this help you? Did you understand VLANs in MikroTik better? Anyhow, in the next video on VLANs, I will probably cover Q&Q and or something like VLANs with wireless interfaces. Feel free to make your requests, and I will see you in the next one.